everyone, Quadratics Example 6. This is similar to Example 5 in that we have a quadratic equation and the coefficient of x squared is not 1, it's in this case 3. Again, that just makes the factorising a bit trickier. Now you might be able to look at that and factorise it straight away. Hopefully you can. If you can't, then you need a method to fall back on. Similar to Example 5, I'm going to use the partition method. So we begin by looking at the coefficient of x squared and the constant term, multiply them together, I get minus 9. Now I'm going to search for two numbers which multiply to give minus 9, but add to give the coefficient of x, which is minus 8. So these two numbers mean to multiply to give minus 9, but add to give minus 8. Now those two numbers are minus 9 and positive 1. If we multiply them together, we get minus 9. If we add them together, we get minus 8. So in the partition method, having identified our two numbers, we then partition the middle term, leaving everything else alone. So this middle term, it doesn't matter what order I write these in. I could put the minus 9 first, then the plus 1, or the other way around. But I would recommend, if there is a positive term, putting that one second. So minus 9x plus 1x, we don't normally bother writing the 1 in algebra. So just to repeat, it didn't matter which way round I wrote those two terms. I'd recommend, if there's a positive term, putting it on the second part. Now, partition method, think of this in two halves. Factorize the left-hand side. These two terms have a common factor of 3x. And then remember the plus? It's the reason I recommended trying to get a plus there. Just makes things easier. Sometimes it's not possible. And then these two terms, all they have in common is a, well, factor of 1. So I'm just going to put them in brackets. Nothing's changed here. If I expanded the line I've just written down, I get back to the previous line, which means I haven't made any mistakes. Important thing is both brackets are the same. So now these two big terms have a common factor of x minus 3. If I bring these common factors out, that leaves me with 3x here, and a plus, and an invisible 1 here. We just don't normally bother writing the 1 in that case in algebra. So there's the factorizing done. And as always, you must check to see if it actually works. So x times 3x is 3x squared. Minus 3x times 3x is minus 9x. And then we've got plus 1x, which gives us minus 8x. And then minus 3 times plus 1 is minus 3. We know it works. We're safe to proceed. Two brackets multiplied together, and the answer is 0. One of the two brackets must have equaled 0. If it was the first bracket, x would be 3. If it was the second bracket, x would not be minus 1. That wouldn't make the bracket 0. If x was minus 1, 3 times minus 1 is minus 3, plus 1 is minus 2. It doesn't work. So you need to write it down in full, then rearrange. We get 3x is minus 1, which means x will equal minus a third. That is the value of x, which will make the second bracket equal to 0.